Hello, good day, Pax et Bonum. So we will be having a short tutorial about what we call the orthographic projection or the orthographic sketch. So the learning competencies here are to identify an orthographic projection and produce an orthographic sketch. So if I will ask you if you can create a 3D model or a 3D object out of those three different faces, how should it look like? So probably you might be imagining the three different faces. They will be able to form a 3D object if you will just fold them. So from the front, you fold the top, and then the right side, you fold it as well. And when you do that, you will be able to form something like a 3D object. But first, you have to be familiar with the different faces of a 3D object. So let's take this controller as an example. When you look at this object, this face of the object will be its front view. Now, when you move to the top of it, so I will rotate it, when you move to the top, this one will be its top view. Now, going back to the front, if you are going to look at it from the right, I will rotate. Now, this one will be its right side view. Now, those three different faces, when put together, it becomes the three-dimensional object. And this is also what happens in an orthographic projection. We create orthographic sketches as plans for 3D objects. Just imagine you are a toy creator. So nobody is expecting you to create toys over and over and over again because you are the only one who knows the specification of the toy. So what happens is we produce a plan, normally an orthographic sketch, and that plan will be sent to the producers or the production company that handles creating the toys. So from the plan, they will develop a model. So that's the reason why we have to learn how to create orthographic projections. So let me give you one example of a 3D model. So looking at this 3D object, based from the top, the front, and the right side, if you fold them, it will create something like this. So normally, the front view of a 3D object, cases like this, it's called an isometric drawing. It rests on the left side of the 3D object. And then the right side rests at the seemingly right side. And then we have the top. Let me give you another example of an orthographic sketch with a 3D model. So we have the top view, the front view, and the right side view. If we put them together, if we fold them, we will have something like that. Now look at this face, the color blue. Now that color blue is actually the front view. Look at the red planes. The red planes is actually the top view. So just look at it. There are three different rectangles. Here, three different rectangles. We have a plane that looks like a letter C. It's this one. Now at the right side view, look at these different planes in green. That is our right side view. So how do we create an orthographic projection? All we need are three different faces. Again, the front view, the top view, and the right side view. Now, let me demonstrate how to develop an actual orthographic sketch. I've listed here several steps that we should follow. So number one is we will draw the front view. Now, let's determine first, what is the front view of this object? So if you have a drawing like this, I've said earlier, it's an isometric drawing. We can divide this isometric drawing into two parts. So can you see this vertex here? That's our midpoint. So we will create a line along the base, and then we will create a vertical line at 90 degrees. So we will divide it into left and right. Now, I've said earlier that the front view usually is located at the left side of the vertex. So the one that I will color in green, that is our front view. But aside from that, if a person is looking from this side, so if his view is from this side, aside from this face, he will also be seeing this face. So that's the first step. We were able to determine which is the front view. It consists of two different planes. So going to our paper, we will draw the orthographic projection. So we need to create a horizontal line, a very, very long horizontal line. It should span across your paper, something like that. Now, we will check the measurements of the front view. Basing on this plan, we know that the height of the object is 3 inches, and the front view, the width is 4 inches. So here, we will create the front view on this part, and remembering the width is 4 inches. So let me do it here. But wait a minute. Since inches is very, very, very huge for the paper, let me just draw using centimeters so that it will be smaller and it will be faster to track. So I will, instead of inches, I will use centimeters. So I will mark from here, 0 up to 4. Since this will be my start, this is 0, what I should do, or what I will do, is to create a vertical line here. So this will be the edge of my front view. Now, why did I place a line that spans to the top? Because the top view will be rested here, so the edge of the front view will also be the edge of the top view. But anyway, more on that later on. Let's draw first the front view. We now know that the width is 4 inches, so it's something like this long. And according to the height, it's 3 inches. So we will measure, here we will measure 3 centimeters. So this is the 3rd centimeter. Now let me place a line. Let me draw a horizontal line. A long horizontal line. So this height and this width, it's actually, wait, let me just erase the slides. And let me put some color. So this one is this side. The width is this. So the next step that we can do is draw this small line. What is the height or width of that small line? We know the width is 1.5. So using your ruler, we will measure 1.5. So where is 1.5? Right about here. So we will measure 1.5 and put a small mark there. Now, I've placed a small mark. Why is it important? That point is this point. Okay, look at the slides. It's the one I encircled. Now, that point is connected to the corner. This one. So what we will do is, from this point to this point, we will just connect and create a line. So the 2 points will have a line. So that one is the inclined line here. Now, next spot or next step, the small triangle. How should we put it here? We know that the height is 1.5. It's 1.5. It's this one. So that 1.5, when placed here, we'll just measure 1.5. So it's this place. Now we will draw the horizontal line. In the 3D drawing, it's a diagonal line, but in the front view, it's just one horizontal line. So we don't need to know the distance or the measurement of the line. All we need to know is the height is 1.5. This one is 1.5. And the line is there. So we'll just connect the line or this point up until the inclined plane. So this now is the front view of the object. Okay? Now the next step is you are going to draw the top view. Wait, let me just write. This is our front. So now we are going to draw the top view using the bounds from the front. When we say bounds, these two lines is what I'm talking about. Okay, so I've projected them upwards. Let me just complete the projection. Now, I've projected the bounds. One good way of keeping the measurements the same of the front and the top is if we will project the different points that was created in the front view. So we have two other points here. We have this one and we have this one. So what we can do is we project them upwards as well with maybe slight marks. Like that. Now, we are going to draw the top view. We know that the width is 4. So the width is 4. What we need to know is what is the length. Wait, let me just clear the slides again. We know that the width is 4. That 4 is this. We need to determine what is the length of this. So what is it? It's actually placed here. It's 3. Okay? So we will measure 3 inches or centimeters on this drawing. And you can place it anywhere as long as it's inside the bounds. So I will start here and then I will get 3 centimeters. So I've marked them. And then what you should do next is from the marks, you create horizontal lines for the upper and lower bounds. You also extend the lines to the right. Later on, it will make sense why we are extending lines to the right. So there is a rectangular figure here. Now, since we've projected lines from the front view to the top, I will write here top because this is the top view. Look at this rectangular piece. This rectangular piece, I'm going to the slides, is actually this one. Okay? What is this width? It's 1.5. What is the length? It's 3 inches. Now, how about the other side? What does these two planes mean? The two planes mean, well, these two actually. But the problem is, it is not fully formed yet. So to form the actual top view, somehow the image of these two planes must appear here. So what is the defining characteristic of the planes here? Aside from this plane seen from the top view, we also have this small rectangle. The good thing about projecting lines from here is we already know the width of that small rectangle. We just have to determine its length. Where should it start? Since it's already placed that the length is 1.5, so we only need to measure 1.5 from the tip. From this point, we will measure 1.5 and then it will form by itself already. So let me measure 1.5. So right about here. And then let me place a horizontal line. So it's already here. Now, can you see the top view already? If you are still having a hard time looking at the top view, let me put some ink so that it will look clearer. So something like that. Now, how about drawing the right side view? One of the first things that we need to do in order to draw the right side view here is if we will create a 45-degree line from the cornermost bounds of the front view. So from here, the cornermost bound, we will draw a 45-degree line that will hit the projected lines from the top view. So after drawing that 45-degree line, any intersection that was hit, you have to put a line downwards. So we have an intersecting line here. We project them downwards. We have a line here. We project it down. We also have another line here. Okay, let me just complete the projection. Okay, so we have projected them downwards. Now, what does this mean? It means that the length here of the top was projected to the right, to the 45-degree line, and then projected downwards. essentially making sure that the length of this one will also be the length of the right side view. Now, continuing with the drawing. We have a point here. Let me just project it to the right. Okay. So what happens now? We must make the right side view appear on this part. But the question is, what is the right side view? How should it look like? So when you have an observer here looking at the right side view, what the observer will see is this part and this part. So first, we have a small rectangle. Actually, that small rectangle is already in the draft. It's actually this part. And then the rest, it looks like a letter P, is also there. Therefore, we can ink this one without having any measurements or additional drawings. So there you go. That's how you create orthographic projections. Now, I have an activity prepared for you. It's already uploaded in Schoology. We have activity 1.1. Now, this is a very, very basic 3D object. I want you to draw an orthographic sketch of this 3D model. Now, you assume that the measurements are in millimeters. Therefore, 10 millimeters is equated to 1 centimeter. If you will see something like this one, 50, that 50 is 5 centimeters. Okay? I'm talking about this one. That 50 is 5 centimeters. This one is 25, so that is 2.5 centimeters. This one, 10 centimeters, and so on. Okay? So after drawing it, take a picture, upload it in Schoology, and I'll be giving my comments. So that's it. Thank you. Goodbye.